Hello, welcome to another episode of Scala Space Podcast. I'm Łukasz Biały, and today with me is Olivier Melois, principal engineer at Disney, working at Disney, also working on Disney Plus platform. Oliver is the author of Smithy 4S toolset, and it's an IDL, it's an interface definition language that allows you to define the contract that binds multiple services together. Oliver, I would like to open with a slightly provocative question, I think. We already have multiple IDLs on the market. Some of them are, I would say, wildly successful, like protocol buffers. Why do we need another IDL?
That's a good question. I think you could ask it with, or you could ask exactly the same question with programming languages. And so it's sort of quite philosophical, but I think that generally speaking, a tool is legitimate as soon as there are users. And so if the tool exists, it's because there was a need, and the need wasn't met by things that were already out there, probably. So yeah, like Smithy in particular, like in the context of this question, Smithy was built by AWS, and it's something that has grown inside of AWS for a decade and a half before they've open sourced it. So that sort of tells you that there was a need within their organization. Now, whether Smithy can be useful to other parts of the industry, I think it is. And as soon as there is a use case for it, then it's legitimate.
Could you tell us a bit more about what kind of an itch AWS had that they needed to invent their own IDL?
Exactly. Yeah. That's the right question, isn't it? So essentially, like, I think it all revolves around baggage, and AWS has been one of the first cloud providers that was immensely successful. And they started with a few services that they had built for their own case, Amazon being an online shop, and decided to sort of sell it as a product to software engineers. And so there was this sort of organic growth of like services being built by AWS and being sort of open to other parties. And when things happen like that, essentially things tend to be a little bit messy. And there's a lot of like ad hoc decisions that are made during the design and the development process of the services. And over the years, like the ways that AWS has used to develop services are sort of scattered a little bit, to the point that it was becoming hard with the sheer volume of services that they're putting out and the sheer number of operations that people can call. It was becoming, or it was getting a bit out of hand, I think. And Smithy, he's an effort to sort of put the toothpaste back in the tube and to create order out of a messy situation and capture little bits of semantics that occur during the development process in a sort of unspecified manner and capture them into something that is well defined and well specified in terms of behavior and expectations. So that's my understanding of how Smithy came to be, and it was the latest iteration of a long process of experiments and efforts, I suppose. Long chain of experiments.
Okay, so I guess it is kind of different to what happened at Facebook, I think, and Google. Both of those companies came up with their own IDLs also. And they also, those IDLs, grew out of the companies and started being used in open source. So Thrift and protocol buffers are more, I would say, you need to rethink your approach kind of IDLs, right? Because what you have to do if you want to adopt protocol buffers or Thrift, you are forced to basically use what they provide. Like you have to use their serialization layer, you have to use their communication layer, or you are strongly pushed
Yes.
towards using them. So how is Smithy different to this approach? Is it not, does it do you have to migrate to Smithy? Like you would have to migrate to gRPC?
That's a good question, and I think Smithy shines when you sort of try to capture existing semantics. So the sort of main selling point of Smithy is like it's a protocol agnostic interface definition language, IDL, and even though it's also true for protobuf to an extent, it's much more apparent in Smithy that it's the case. The proto IDL was, or when you read the documentation anyway, they sort of state that the proto IDL is not necessarily tied to the protobuf serialization mechanism, and that gRPC is not necessarily tied to the protobuf serialization mechanism either, or the HTTP2 is a transport mechanism. But in practice, like when you use the proto IDL, you're going to use the protobuf serialization mechanism. You're going to use gRPC as a transport layer most of the time. There are efforts to sort of decouple a little bit, and products like gRPC Gateway, which allow for sort of taking a protobuf or a proto specification and create an HTTP REST JSON kind of gateway to talk to protobuf services. But yeah, you sort of have to buy into the concepts and not gotchas per se, but yeah, like you're buying into one way of doing things, and sometimes it works well. Like if you've designed your system with those constraints right from the start, it's usually very good because it sort of saves you a lot of work sort of getting those solutions directly from the shelf.
Yeah.
But when you have an existing product, existing services, and an existing architecture, and you're just trying to sort of retrofit them into some format that is formal and well-defined, then it becomes harder to sort of move into the proto IDL or to the first IDL. So I think the story there for Smithy is much better in that regard. And also, I think the more direct competitor to Smithy in a way would be the newly released TypeSpec IDL from Microsoft, which overlaps greatly in terms of concepts with Smithy. Yeah.
So the idea is to cover existing APIs with something that can be then used. So
yeah,
what does it mean that it can be used? What are the use cases or rather uses?
Yeah, so uses are plenty. Like it's because the most natural one that we think of is like describing HTTP REST JSON APIs in Smithy, and that's a use case that you get features like relevant features out of the box to describe those things. But the fact that it's protocol agnostic allows it to sort of capture a number of be useful in a number of use cases that could run from like data definition for databases, things like I can't really say too much about some of the use cases that we use it for, but like tracing, like understanding that some bits of a particular payload could be used for tracing or logging or some things like that. Like the way that Smithy works essentially is that you have a set of core semantics that lets you fundamentally, or that sort of pose the foundation to describing data and operations, and then you sort of enrich those definitions with annotations. And the annotations can come either directly from the Smithy standard library or from your own libraries of annotations or your own specification themselves. Like you can create your own annotations, for instance. And it's by this annotation mechanism that you create new semantics and new protocols to be used within, like the whatever use case you can think of.
Okay, so Smithy is trying to basically cover anything that could be constructed as an interface. Am I getting this correctly?
Yeah, or lost like a great number of things. Like it's not trying to sort of compete with GraphQL, for instance. GraphQL is very specific in the IDL landscape.
Oh, okay.
I think, and in the protocol landscape, if you sort of consider it a protocol, which it kind of is. But yeah, it's sort of, you can potentially, and you can capture the proto semantics in Smithy. You can capture JSON semantics in Smithy. You could capture Avro semantics in Smithy, for instance. So yeah, like you can sort of capture a bunch of different use cases in Smithy.
Okay. Could I ask, provided that it's not covered by some NDA, could you tell us about the origins of the Smithy 4S project, how it came to be?
Yeah, it's actually an interesting story. So originally, it was we had a hackathon back in 2019, Disney Streaming, or when it was called Disney Streaming back then, and I led a project that was aiming at doing a pure Scala DynamoDB client. So something that would not actually wrap the Java client for DynamoDB, but rather co-generate a client that would, do what the client is supposed to do in order to talk to AWS. And started from there. And so within 24 hours, we had a working DynamoDB client that was fully generated from a JSON file that the source of truth at the time was a JSON file that we found in the AWS Java SDK. And so turns out we won the hackathon. Like it was it was actually funny that we did, and it sort of gave us a little bit of legitimacy to keep working on this project when the time permits it. So going from DynamoDB to sort of over AWS services and see whether it was working. And turns out we were very lucky by choosing DynamoDB as a sort of prototype thing to do, because the protocol that AWS uses for DynamoDB is very simple. It's sort of JSON in, JSON out, where the full payload of the request is going to be encoded as JSON, and the full payload of the response is going to be encoded as JSON. And so the most complex part is sort of nailing the signature algorithm that lets you authenticate with AWS. So anyway, like at that point, it was a friend of mine, Anton Zviridov, who's quite active in the Scala community, and myself, who sort of took it upon ourselves to keep developing on our free time or when we had breaks at Disney, like this sort of AWS pure Scala SDK. And we realized that, like we had selected the easiest service to prototype it with, and that actually Smithy, or sorry, not Smithy, but AWS had 5 different protocols that they were using across their services, and some of them were pretty easy to implement, and some of them were quite on the harder part of the spectrum, with like XML being involved and a lot of things that were more or trickier than just writing JSON decoders and encoders. And so we got stuck when we started playing with S3, because we noticed that the specification that we had found for the S3 service wasn't matching the documentation. And there were some endpoints that we weren't able to co-generate because of this mismatch. So we sort of emailed AWS to ask them, like, can you sort of give us, a file, like a CSV file or whatever, to let us know like the mappings between, the source of truth that is supposed to be a source of truth and the actual reality of the service. And so we got into a meeting with them, with a few AWS engineers, that is, and they sort of gave us the final question, but they also told us, like, oh, but by the way, we're sort of putting out this project that we've been working on for a while, which is called Smithy, which is a much better format that the JSON files that you found. It's like the modernization, or it's the next step of those things, and like they gave us the link to the open source project that I recently put out, and it was interesting. And so I started playing with the tooling, like in addition to being a specified syntax and semantics, there was some Java library that you could pull and use to parse Smithy files and validate them and stuff like that. And as I was playing with the language and trying to understand the concept, it became quite clear that it was really, really well designed. Like there was a lot of very good design ideas that went into it, and that it was probably going to be a good fit in order to capture some of the semantics of some services that we had at Disney that were hard to document otherwise. And so I started where we had an over-hackathon. Sorry, the phone is ringing. That's gonna sound. We had an over-hackathon the next year, I think, and played, or once again tried to rehearse the idea. We didn't win anything this time around, but what we did, however, was like create the initial LSP implementation for Smithy to have good editor support, and a prototype code generator that was feeding off Smithy. But instead of trying to talk to AWS, was trying to have an HTTP server. And the goal was like, can we get something that devs would like to use to define their APIs, as opposed to defining them or specifying them in OpenAPI, and get better tooling, get linting, get a good editor experience that would give you like jump to definition, diagnostics, auto-completion, this kind of stuff. And so after this POC, I sort of took a little bit of my free time to sort of refine it and have something that would be an MVP, and started like showing it to a few teams. And there was a team that was interested enough that they agreed to kind of try it out for their own services, and they were really happy with it. And so it sort of, from this relationship, we refined the library a little bit. We've fixed some bugs. We expanded the coverage of the Smithy IDL, and the rest was basically organic growth. It was like teams speaking to other teams saying, "I use this, like it's really good. It saves us a lot of time and effort." And yeah, that went organically. There wasn't a top-down decision to say we should be using Smithy. It was more of an organic growth kind of thing. And after a couple teams started adopting it, there was somebody high up in the hierarchy who noticed the project and agreed to hire a couple of people to help with the development. And that sort of formed a team of people, and yeah, like we've sort of worked on Smithy tooling and Smithy for us ever since. Or like, yeah, there's a lot of things to say about how the project is going right now. But essentially, Disney has sort of a dedicated team to work on Smithy tooling and like API registries and this kind of stuff within the organization. And now, that's it.
Okay, so I think it sounds like your workplace basically repeated the same situation that AWS had, right? Because there was no big migration. There wasn't, we're adopting this technology, rewrite your stack in 2 months. Nothing like that. It's just adoption and...
Yeah, it's like organic adoption, organic, like being interested, and the fact that you don't necessarily have to, like some teams sort of did the work of specifying their APIs a posteriori in Smithy, covering what they had already implemented, and like slowly transition to the code-generated routers and reverse routers. But yeah, there wasn't a big bang kind of let's switch to this kind of thing. It's really been organic as much as possible, and people have been really happy with it.
Okay, and from what you're saying, I get that it seems that there was a boon to productivity. It wasn't just, okay, let's make things more systematic, let's make things more clean. It was something that started benefiting the development teams by just adopting that.
I mean, it's sort of a virtuous circle kind of thing, because if you do have tooling that gives you some guarantees that your implementation is going to match the specification, you have an incentive to use the specification format. And the more people use it, the more people are incentivized to use it, essentially. And I think like having this sort of one way of talking about APIs, like it's a separate format. You don't have to read the implementation. You don't have to sort of jump into another team's code base in order to see what the API is actually like. You get a neutral space where people can open pull requests and discuss it. It's quite organic and it's quite natural for development teams to abide by this process. And then, the boon of productivity is quite, or was quite noticeable for teams that were in particular starting new projects. Like we had a few teams come to us and tell us, we've been able to meet our deadlines thanks to the tooling that you've put out. So that's a huge validation point for us,
That's really impressive. So maybe we should put a face to the abstract name that we have.
Mm-hmm.
Could you show us how Smithy actually looks like?
Yeah. Okay, let me share my screen. Up, screen 2. There you go. All right. Let me know when you can see it. Can you see it now?
Yep.
Yep. Cool. All right. So this is the project that I've generated from SVT, from a GitHub template. It's type SVT new. Like Smithy for us is actually part of the list of the projects that are provided out of the box, like just without having to have the reference to the template itself. So I generated it from this, and I've sort of removed some stuff to make it a little bit clearer to people who are probably not familiar with the IDL. So we're gonna go through this example. It is very, very sort of simple. It's a hello world service that has a single operation called hello. Hello takes an input that's a person, and the output of the hello operation is a greeting. So as you can imagine, like you sort of provide a name and you get a message. So operations, inputs and outputs are or must be structure data types. So you have a structure is basically like your case class. It's sort of a product type or a record type in a way. It's a number of fields that are going to be grouped together in a data type. And there's a bunch of primitive types that Smithy provides you with that are going to be the leaves of your data definition. So you have string, you have Boolean, you have the usual numerics, integer, longs, floating numbers, doubles, big integers, big decimal. You have timestamps, which indicate like a point in time. You have JSON or basically it's called document, but it's just JSON, ADT. And it's sort of a pragmatic decision to consider that document or JSON is a primitive type. And it's actually quite useful. And that's about, and bytes, like a byte array or blobs, which are byte arrays. And additionally to that, you have a bunch of, so you have like enumerations, and then you have lists and maps, and you have unions, which are the dual of structures. So it's like if structures are a product type, unions are the co-product or something.
Sure.
And so those are the semantics, like the core semantics of the language.
Sure. You mentioned that it's completely agnostic in terms of how those data types or whatever those things are going to be transmitted, or where they are going to be transmitted, how services and operations are going to be mapped, right?
Yeah.
So I'm curious, is like this structure that we have here, is this basically a body JSON of HTTP requests?
Not necessarily. And that's the thing. It's a good question, but it's not until I've put some definitions or some annotations on those data types. Right now, I'm just thinking of the modeling in terms of like business level requirements or domain specific constraints. I'm not thinking about the serialization, and I can go a bit further than that. Like I can actually define like what would be like new types or opaque types in Scala and do this kind of thing. So I can sort of really have a fine-grained modeling of my business domain. And then in order to sort of give meaning to this particular specification in the context of a sort of REST JSON HTTP kind of protocol, I'm going to annotate those things with specific annotations that are understood to formulate or to capture the details of like how does this thing get transported to another service during a remote communication. So let's try and do that, shall we?
Sure.
So I'm going to start to say that the service is a simple REST JSON service. So this annotation here is one that's provided by a library of Smithy trace called Alloy, which is maintained by Disney. And it's sort of companion library to the standard Smithy library, if you will, and it adds a little bit of semantics that we found to be useful coming from the industry. And so here I'm sort of saying, okay, my Hello World service is going to be accessible via HTTP using the sort of simple REST JSON semantics. The semantics are sort of documented in a document elsewhere, but just by doing this, essentially, I'm starting to get some validation error popping up. And here I get one that says operations that are tied to this simple REST JSON thing must be annotated with the HTTP trait. All right. So we're going to try this, and we're going to put the HTTP annotation. The trait is an annotation in Smithy lingo. And here now we've got, you have the HTTP annotation, but you're missing the URI number. So I'm going to do like hello, for instance, and I'm getting another error saying, well, you need to put the method as well. So we're going to say it's a get call. All right. And now there's another couple validation errors that show up. So one of them is saying, well, get methods are supposed to be read-only, so please sort of signpost the operation with the read-only trait. But more interestingly, basically this is saying, well, we have a get operation, but there's a bunch of inputs there in the input of the operation, or a bunch of fields in the input of the operation that I'm not sure where they should go in the request, because get requests are not supposed to have bodies. So I need to sort of go and tell my specification, like, where is this name supposed to go if it's not in the body, or where is the town field supposed to go? So here what I'm gonna do is I'm gonna add a segment here. That is gonna match one of the fields. And I'm getting a new error saying, okay, well, you have that particular HTTP or HTTP segment that matches one of the fields of your input, but you need to sort of annotate this with an HTTP label annotation to say, yeah, like this is actually supposed to be mapped to the segment here. And now same thing goes for the town field, like it's there, but it's not part of the HTTP metadata. So Smithy says, well, if it's not part of the Smithy the HTTP metadata, it must mean that it's part of the body, but GET operations are not supposed to have bodies. So
Yeah.
let's do something like HTTP query from, there you go. And now our specification compiles. And like very simply, just by looking at it, it should be easy to understand what is actually expected. Like you have a GET HTTP request that's supposed to go to that path, and that particular segment of the path is supposed to, or is tied to that input. So I'm going to extract it and put it in this field, and then for that particular input field, I'll try to find it within the query parameters of the request. And this will sort of be the body of the response. Like it will be a JSON object with a message field inside. I can tell Smithy that actually I want the dev field to be the whole body of the response by saying HTTP payload here. And basically that indicates that rather than having a JSON object with a message field, there should be just a JSON string in the body of the response. And that's basically how you go from your domain-specific semantics into something that is protocol-specific and that has meaning in the context of HTTP and JSON.
Okay, I think I'm kind of getting an intuition, but I'll ask anyway. How would you add errors to this?
Yeah.
So usually you have multiple failure modes for APIs, right?
Yeah.
If parameters are wrong or there's a mistake, how would you do that?
Yeah, exactly. So essentially, operations can have inputs, outputs, and also errors. So input is you have a structure that's an input. The output, you have a structure of the output. If it's not there, Smithy assumes that it's basically an empty structure instead. And for errors, you can define your own error structure. So let's do something like structure not welcome. And we're gonna annotate this particular structure with the error trait. And the error trait is expecting to receive either a client or server as ability to say, well, this is a client error or server error. I put it as a client error. And right here, I'm just gonna fill the errors fields with this particular data type here. If I had not annotated this with the error traits, I would get an error saying, well, this particular type cannot be bound to the errors of this operation because it's not actually an error. There you go. And then additionally to this, so by default, essentially, if you have no other information than this, the expectation is that this error, when happening within your implementation, would translate to a 400 HTTP status code. And you can refine that by saying HTTP error 401, for instance, for unauthorized. And then the expectation becomes really clear. Like if you get a not welcome error within the implementation, it will translate to. And so I can put some things exactly like I've defined my response there. I could put like I'm going to have the required error message string and maybe something like error code integer required or something like this.
Okay.
Yeah.
So I've noticed that you have all those traits, right? That you didn't provide any imports for them. So I'm assuming, correct me if I'm wrong, but I'm assuming they are part of the language itself. Like
they're part of the standard library. So if I jump to the definition of, say, error here, we can jump into this. And this is the sort of file that contains all the constructs that sort of form the standard library of Smithy, and they're within the Smithy.api namespace. So you get a bunch of like primitive types, and you get like a a number of things that have to do with HTTP or JSON, etc. And those Smithy.api things do not require import in a similar fashion that when you call lists in Scala, you don't need to do import style.lists. But for the simple REST JSON, which is a thread that's provided by a separate library, then you do need to have a use clause at the top of the file to say I'm importing this. Or you can use fully qualified name here, like I could do something like this and it would have the same meaning. But I can also jump to the definition of that and see like the definition of the protocol essentially.
Okay, so the language itself is extensible to a high degree, to the degree that allows you to basically define your own protocol, if I understand it correctly, right? Because
yeah.
Okay.
So a protocol, just to sort of elaborate on this, like if we go back to this, a protocol is essentially a list of traits that are supposed to be implemented by the implementers. So it's like saying, I've got this set of semantics that if implemented correctly, is going to come with a guarantee that two implementers will be able to talk to each other. And that's quite useful in that it sort of reduces the scope for tooling builders or implementers in order to build compliant tooling, essentially. So it really sort of reduces the scope to something that's achievable and exhaustively, listed. And so that sort of differs from OpenAPI, where all of the HTTP semantics are sort of crammed into the same thing. And if you try to implement support for OpenAPI as an IDL, you're going to cry really, really fast because there's so many things that you need to take care of, and some of them are really not necessarily playing well with one another. So having this sort of notion of okay, we have an IDL, and within this IDL, there may be like several protocols, and each protocol is a list of like a reasonably small list of a number of things that are relevant. It really helps driving the tooling. It really helps like assessing like how much you've covered in your implementation and this kind of stuff.
I think this pick and choose nature is very interesting. It's very different from anything else that I have used in the past. So for gRPC, if your implementation of gRPC generators doesn't do something, it just won't work for you. You can't do anything about that. Or so it's all or nothing basically. If it's not covered by implementation for gRPC for your language, you will get a runtime error most of the time. In this case, it's a bit different story, but it kind of looks to me like it's going to create separate ecosystems, right?
Yeah.
I mean, one company can define things that they pick and choose to have, and the other can do something completely different.
Yeah, absolutely. And it's already the case. And I think to a degree, it's a good thing rather than a bad thing, in the sense that every company that's large enough, every company has baggage, every company has some sort of little details that will not be covered by some out-of-the-box tooling, and having something that lets them capture those things and give them a principled way of capturing those details is really, really valuable. And I think it's like the expectation shouldn't be that you're gonna get into a company that uses Smithy and just be completely 100% clear about what essentially their Smithy tooling does. But it will give you a good basis for understanding what the tooling does. Essentially, it's that little bit of a difference really between something that is extremely like prescriptive, like a gRPC protocol, to something that's more fluid in the sense that each organization can define their own semantics or sort of pick and mix the bits of semantics that they're interested in or create their own completely protocol. One interesting bits of our simple JSON protocol that's sort of coming with support out of the box in Smithy for us is the fact that we're reusing traits that are provided by the standard library out of the box. So there is a notion of overlap a little bit, where there's not a 100% guarantee that any service that uses the simple REST JSON protocol will be able to communicate with something that would be using the AWS REST JSON protocol. But there's a reasonable level of confidence that if you have a Rust code generator, for instance, that understands the AWS protocol, chances are it will be able to speak to a service that would be implemented in Scala against the simple JSON protocol. If that makes sense.
Okay, so it looks like universality is not the goal here, more like internal consistency, because the one company that decides to adopt Smithy will, by just the same process that you described before, by teams talking and putting tickets to team that implements stuff in Smithy implementations.
Yeah,
it will gravitate towards something that works for this company, but it's not necessarily guaranteed that the same thing will work across companies. There's no guaranteed universality like with gRPC, for instance.
Yeah, absolutely. And whether it's a good thing or bad thing is discussable. I think it's a good thing. But yeah, I can understand why it'd be why in some cases people would be reluctant to adopt Smithy over something like Protobuf. Like if you have a greenfield project and you're working, in a small startup trying to get things out of the door as fast as possible. Like if you have an architecture that requires services to talk to one another in your backend, then going with gRPC is probably a safer bet because they're tooling for a vast array of different programming languages that is guaranteed to sort of work with one another. But it may be that at some point you're going to have some use cases, down the line where the proto IDL will not be flexible enough to let you describe those use cases very, very well. So sort of the trade-off is like, you get more out of the box, but chances are it won't be as flexible as you'd like it to be down the road. But yeah, like it's really dependent on, I think it's like everything, like the best IDL to choose is really dependent on the use case. It's really dependent on the company. It's really dependent on the programming languages that you use at your company, on the culture, on whether you have like people who are passionate about building tooling for others, or people who are just wanting to work on feature work, this kind of stuff.
Yeah, I was just going to say that it seems like Smithy is awesome at sorting out the tech culture at a company. Okay, I wanted to go back to the examples that you're working on. So what is the extensibility story for a Scala developer? What can we do something Scala specific with Smithy, for instance?
Yeah, sure. So an example is that like Scala developers like their types, and they like things to be reflected in types, like constraints and particular rules, etc. And that's a feature that's also slightly like it's similar to a feature that's provided by Scala PD, but we have a feature to essentially state that a specific trait is meant to be understood by the code generator to have a conversion between the type in the specification to a type that is Scala specific. That would sort of be added, that would have like constraints directly baked in the type itself in a way. So as an example, we're gonna do something that's gonna add a phone number on a person. So actually, we're gonna start by saying like string phone number. All right, and I'm gonna add a field here. Phone number. We're gonna be optional. We're gonna put it in a query parameter like phone. And what we're gonna do is, like, if we co-generate it like this right now, well, we get a compiler because I've got a little program associated to this project that essentially wires the co-generator within a HTTP server. Oh yeah, actually, so right now, when I do this, if I go to the generated code of this operation here, so the generated code, the generated code is a little bit scary, but there's a hello method that matches the operation, and you can see the input is the person here, and we can see that this phone number field being generated with a phone number type. This phone number type is it's actually, it's not gonna let me go to the definition of that, is it? Source managed. There you go. So it's all sort of a new type. So within, like, out of the box in Smithy for us, when you do something like this, Smithy for us will generate a zero allocation wrapper that will be named after. So it sort of gives you an additional level of type safety. But imagine that you want to have validation for this stuff.
I was going to ask how you validate that. But...
Well, yeah. So out of the box, without any more information, Smithy for us is not going to be able to do that. So what we're going to do is basically write the necessary machinery in order to let the co-generator understand the fact that it needs to, instead of generating a phone number new type, it needs to sort of generate a reference to a type that you control, that you've handcrafted in your Scala code, or maybe pulled from a library like Google's phone number library or whatever. So we're going to create a validated phone number case class that is going to be backed by a string. I'm just going to change the references here.
Well, that won't compile.
Yeah, there you go. So here I've just created a case class, and within this case class, I've implemented a refinement provider that actually, let me just bring this, put it again. Right. So here, essentially, I want to sort of have a type class that says, if I've got a string, and that string is annotated with something in Smithy that's a phone number format, then I'll generate it as a validated phone number. So we're gonna create a trait. That's gonna be like phone number format. And that's how we create custom annotations in Smithy. We just create a data type and we annotate them with the traits to say it's a trait itself. And so by virtue of having this, I can now use this data type as an annotation here.
Okay.
All right. So I'm sort of giving a little bit of meaning here, saying, well, this particular type is not just a string, it's a string that's also supposed to be valid against the phone number format. So now I'm going to recompile this, and it compiles because the phone number format annotation was actually generated. So if I look at the generated code here, source managed, what did we call it? What did we call it? Phone number format. Yeah. Here. There you go. So here, we've got an empty structure on the Smithy IDL, so it translates to a case class that doesn't have any fields, and it has some sort of construct in the component object to capture the structure of the data type, etc. So now I've got this piece of logic that says, okay, well, I've got this provider which refines the string into a validated phone number as long as in the Smithy specification it's annotated with phone number format. So now we need to sort of tell Smithy for us that when it looks for things in Smithy, when it sees that, it needs to understand that it should be generating things as our validated phone number here.
Okay.
So what we're going to do is we're going to add on top of this thing, we're going to say, well, it's also not just a trait, it's also a refinement. And this is provided by the Smithy.meta refinement. Okay, so what do I have? What have I done wrong here? Smithy.meta refinement. I'm just going to put this at the top of the file, see if that works better. Yeah, it's probably because the protocol, yeah, it should have it. The target type must be provided, yeah. So, okay, it compiles well. Just let me just look at the documentation again, because I don't remember exactly how to use this. Okay, so it starts target type, and we're gonna go here, and it's common example validated phone number. Validated phone number. All right. Okay.
So it integrates quite deeply with actual code that is being generated in this case a Java or Scala language, right?
Yeah. Yeah, in this case it's Scala. Unfortunately, as you know, the gods of demos or live demos have decided demos never work.
Of
So
course.
just gonna check that in theory. So phone number format, and clean the thing. Now if it's in tiles. So why is it not happy? Is it that I should maybe just have the string here instead and annotated with phone number format? Would that work? And no, it is supposed to be a. Okay. Phone number format, yeah. And I schemas. Oh yeah, because it's sort of now we've got the new type wrapping or validated for number. Okay, so in theory, I should be able to do something like unwrap here to say that we don't want it to be wrapped. I'd rather it to be directly cool. Clean, compile. Yeah, there you go. So now I get a compiler because in my little program here, I don't have any phone number. I should be using validated phone number. And this works. And so now, essentially what's going to happen is that when, say, I receive a request, that bit of validation will be exercised to verify that it matches the implementation rule that I've handcrafted there. And I don't have to do this wiring myself, like it's all automatically done by virtue of having this trait here. It basically tells me for us when you decode a piece of information that's a phone number or that's a field or a data type annotated with a number format, you need to go through the validation that's within this that's associated with this validated data type.
Sure. Just out of curiosity, is this possible to be used with, let's say, Rust implementation? What's the story if we wanted to have the same thing working in Rust or Python?
Right. So yeah, that's where the sort of thing breaks, because in order to have it working with Python, you would have to sort of ensure that the Python tooling has an understanding of this particular phone number format annotation. We've created this mechanism in Smithy for us to let users with reasonably few lines of code to wire in their validation within the implementation of our interpreters. But Python tooling is probably not going to be aware of this, or Rust tooling is probably not going to be aware of this. So basically, if an organization decides that, yeah, there's a mechanism that will let people tie in some arbitrary traits into the code-generated or the behavior of the runtime interpreters that is consuming the generated code, then they have to go and implement it in their Rust code generators or Python code generators. Yeah.
Okay, I get it. You've already shown us that there's some code that is generated for you, but you didn't change anything in the generated code when you had the main of the program, which was basically running the whole program, the interpretation of all the whole effect that the endpoint is. How does it work? What is the internal story? If you could explain that to us briefly.
Sure. All right. So the way that Smithy for us work is that it creates, or it tries to sort of replicate the protocol agnostic nature of the Smithy IDL by co-generating things that is not going to be tied to a specific serialization format or a specific transport mechanism. So it sort of generates some data structures that conform to an interface or a type class, if you will, that interpreters are going to be able to tap into in order to generically provide some behavior against those generated types. So we have this sort of set of abstractions that sit in between the generated code and whatever you want to do, so that it can work with any of the generated code, essentially. The entry point of one of the interpreters that we provide with out of the box in Smithy for us is the simple REST-JSON builder. So what it does is basically provide you with this one-liner root method that will expect an instance of a service. So here, what is generated for you is basically this hello world service interface that you implement in your own code, like any good old, object-oriented interface. So we've defined a hello operation. We're implementing a hello method. We're really simply, and this one-liner is essentially going to take this stuff and produce an HTTP route by looking at the abstractions that are associated to the hello world, or the instances of the abstractions that are associated to the hello world service, that essentially say, well, this hello world service has all those operations, and for each operation you get an input schema, an output schema, an error schema, this kind of thing. And for each schema you get the set of traits that came from the specification. And just by writing the interpreters in terms of the schemas as opposed to the data types, we're able to have this sort of completely generic behavior. So every time I change something in the specification, all I need to do is basically amend the implementation in order to take care of potentially new operations or new inputs or new bits of outputs and get the code to compile. But I don't need to care about, or I don't need to do anything specific that is HTTP related. The framework or the library does it for us, like the interpreter does it for us, essentially. So I just need to take care of the domain-specific level of what has changed in the specification. All right.
Sure.
So if we have a look at going back to the person, for instance, because that's reasonably intuitive to understand. So a person, if we put it side by side with specification, so split left, and here, yeah. All right. So person, you have a required name, you have an optional town, an optional phone number. So here, required name, optional town, and optional phone number. So that's the data type. And within the component object of data type, there's a bunch of things that get generated, and in particular, the schema construct. And the schema construct sort of captures the details on how to deconstruct the data and how to reconstruct it. So for each field, you get something that's going to capture the accessor, the name of the field, the various traits. You call them hints within Smithy for us because trait is a Scala keyword. So all the details that are found in the specification are accurately translated in the generated code without any sort of coupling with any kind of meaning that we would give to those particular things. We're not actually interpreting any of those traits at the level of the generated code. It's the runtime opt-in libraries that will be able to look at those schemas and say, okay, well, I've got enough information to compile or to produce a JSON codec or a codec that would read information from path parameters or query parameters or headers, etc. And basically do it completely generically. And I don't need to know what is the data type. I just need to access all this information to have access to all the accessors and to the constructor of the data in order to recreate those things. And that's how it works for data types. And that's also how it works for services, where each service can be deconstructed into a bunch of operations, and each operations can be deconstructed into an input and an output, etc.
Okay, so all the data is completely generic on the Scala side, right? The generated data types and traits are basically, they don't have any functionality themselves. They just provide information about shapes. So that means that if we wanted to have another kind of interpreter, let's say for direct style of Scala, it would be it would boil down to implementing the interpreter for those data types, and the generation of the code would stay as it is. It's just
exactly
what takes those data types and generates, or rather serves them. Oh, that's a very nice design.
And that's something that we greatly benefit from internally. Like we have put out one interpreter for HTTP for us, but internally we also have interpreters for other things, for other frameworks that are used within the company, and for other use cases than just HTTP or JSON. We have not surprisingly, like we've got an interpreter that produces DynamoDB codecs from the generated data type, so that you can easily like serialize and deserialize DynamoDB attribute value payloads into the generated code. So it works very well because we're able, with a very small number of people, to cater to a reasonably large and heterogeneous set of teams that have made independent decisions with respect to the frameworks that they want to use in their applications and stuff like that.
Okay. I do have some additional questions that I wanted to ask. And those mostly regard comparisons. It's already kind of obvious that comparisons with more
opinionated
batteries, opinionated or batteries included IDLs are kind of like comparing apples to oranges.
Mm-hmm.
But there are some things that I think are quite interesting to think about. So one of the most major roles IDLs are expected to help with serving is to provide guidance or help with evolution of APIs, and that's always a very problematic area of API design and maintenance mostly. How to safely evolve an API so that it doesn't break stuff or any parties that are using it. What is the story for that in Smithy?
All right. So Smithy, as in like the full set that is provided by AWS, is reasonably low level. Like you get a compiler that takes care of the parsing, the validation, like with extensible mechanisms that you can inject validation into. And you get a bunch of other things. And in particular, you get a Smithy diff library. The Smithy diff library allows you to sort of take two Smithy models that would have been loaded from, say, different versions of a repo or maybe different artifacts living in an artifact repository, and basically compare them with one another. And there's several ways to use Smithy diff. The lowest level way is that it's going to give you a diff structure to tell you like, this field has been added, this field has been removed, this trait has been added, this trait has been removed. And you can build your own compatibility rules very simply based on that, because the semantics of the IDL, like the core / foundational semantics, like the structures, the data types, etc., they're really simple. So building something on top of this simple Smithy diff function is quite natural and quite simple, and it can sort of, you can capture very, very specific rules that are specific to your organization. And that's what we've done. Another way to consume the Smithy diff library is sort of to have a higher degree of or high level validation thing, where it's a little bit similar to the validation rules that we've had here whilst I was typing the specification, in that you get an extension point or an SPI. So SPI meaning service provider interface. So it's a standard JDK mechanism that lets you add plugins to a bit of software, and you can sort of inject validation rules this way. And AWS has a bunch of baked-in rules that work for them, and they're encoding the rules that they've refined over the years to ensure that it makes sense, or that evolutions of their specifications make sense. And it's up to an organization to decide whether they want to abide by the same rules that AWS has formalized, or whether they want to sort of create their own set of rules. I'll say the following, like the AWS use case is quite pragmatic within the boundaries of AWS, because the way that AWS sort of tackles code generation is that they're taking on the task of generating the SDKs for their users. So they, modify the specification, and then they generate the SDKs for Java, for JavaScript, for like all the languages that they support. And as a user of those SDKs, you consume them as libraries. So because you consume them as libraries, there's some expectations that you're entitled to have as a library user with regards to source compatibility and binary compatibility in particular, additionally to the compatibility rules that are coming from the API level. And so the rules that are baked in Smithy diff, when you use this sort of higher level, like diff validation kind of mechanism, they make sense when you take that into consideration. When you take into consideration the binary compatibility / source compatibility level of the APIs, but they don't necessarily make sense when you think about the API in isolation. So to give you an example, so in a service that you maintain, that you implement, if you change an output of an operation to add a required field, it's not a breaking change because you're sort of giving more data to your users. You're not asking more of them. And if the users didn't need this data or was using a previous version of your API or whatever, it's just not going to be aware of the fact that this data is present in the response that you give them, and it's just going to disregard them. So it's going to continue working as expected. However, like if you add a required field in an SDK in the output, that's not like if you think in terms of like Scala binary compatibility, that would imply having a new field in a case class that is required, that would sort of break. Wait a second, I've got it backwards. Yeah, you would be breaking, or you would be at risk of breaking some sort of compatibility there. So what I'm trying to say is that they sort of really fitted their API evolution rules to also contain semantics that have to do with evolutions of libraries and SDKs. And it's not necessarily what you want, but you're free to disregard this aspect and basically just build your own stuff. The really important part is that you have the foundational functionality that lets you compare to models and access a very, very workable diff data structure that lets you understand what are the differences. And from that, it's really easy to build compatibility tooling. And that's what we've done at Disney. So it's not really something that you get fully baked out of the box, off the shelf kind of thing. And it's just that the foundations are there. They're really good. And it's up for you to sort of leverage them to make use of them within your organization.
Mm-hmm. In the same vein, talking about things that you get out of the box, I was curious. With OpenAPI, you usually get a Swagger endpoint, right?
Yeah.
There's Reflection API in gRPC. Some services, some public services do have it. So, it addresses the problem of what is currently running on given environment, and this kind of Reflection API or just schema endpoint, they allow you to introspect into whether your request, whether your client that you're going to use is going to fail. Is there something like that is available for Smithy, or is it another thing that it's kind of like build it if you need it?
Yeah, it's sort of a build it if you need it kind of thing. Smithy is not really prescriptive in terms of like whether or not a reflective endpoint should be made available within the protocol, because it's protocol agnostic. So sort of arguably you can say the reflective endpoint is supposed to be there in a gRPC service, and the tooling is just going to provide it for you. But considering Smithy is protocol agnostic, it would be counterproductive to try and force this decision onto people who are defining new protocols. However, what we've done in Smithy for us here, like actually, we've got a one-liner. What we do is essentially like when you cogenerate your Scala code within Smithy for us, we're also going to cogenerate an OpenAPI translation of the Smithy specification in order to facilitate the serving of such an endpoint. So it will sort of serve a OpenAPI view of the specification that you've written in Smithy, but it's sort of similar. And it would be reasonably easy to do the same thing, like just serve the Smithy specification itself. But then there's always like a because the Smithy specification could potentially contain things that you don't necessarily want to expose to the user. So it's very like use case specific. And to a degree, like Smithy is also built with this use case in mind, that basically your source of truth and what the users see of it are not necessarily the same thing. And potentially you're going to have some endpoints, or it's the case for AWS actually. Like they have some operations that have pieces of information that they only grant to like premium users or early adopters of some things, and they will sort of give those users some SDK that contain more than the SDK that the rest of us consume. So there's this sort of this aspect of like making it easy to pre-process your specification, to refine it to target specific use cases, like who's calling me, or are there some more pieces of information that I should be adding, etc. And so that sort of goes against having a universally defined way of like exposing what is running on a service in a sense. So it's up to organizations to decide. But yeah, we like in Smithy for us, open source, we have this sort of facility to co-generate the open API schema, and we also have this one-liner in an opt-in module that essentially will take the schema where it's located in the resources of your project and serve it as a Swagger UI, kind of web page in your service. Yeah.
Okay, so let me summarize this a little bit, as I understand it, of course. So
Yeah.
Smithy basically is a platform. It's not IDL in the strict sense of the word. It's more like a platform to build IDLs on top of that, in the fact that it's completely agnostic about what you're going to do. So there are some built-in, let's say, things that are supported, built by AWS, but it's more of a story where you take what you want and build stuff on top of that. And
Yes.
then Smithy 4S is an implementation of a tool set. It's also not an IDL in itself that, you just take it off the shelf and off you go. It works, does everything. It's also something that is meant to be extended to fit the needs, the particular needs that you have.
Yeah, absolutely. Like the generative code that's produced by Smithy for us and the core runtime library that the generative code depends on is built to maximize the number of use cases that you can implement on top of it. So it's really like not trying to be prescriptive at all. And it's more trying to give you the building blocks in order to build your own tools. And that's something that has worked extremely well for us internally at Disney, but also our open source users have come up with all sorts of very interesting use cases for this stuff. Like there's a company that has really simplified some complex workflows that were taking them like a week or 2 weeks to handcraft and build, like refine everything or a lot of those things to be driven by Smithy schemas instead, and basically have shrunk this sort of 2 weeks workflow into a half-day workflow, which is like it's a huge gain of time and money and effort. There's some individual users who are experimenting with like using Smithy as or Smithy for us to derive a format, to derive a kind of specification format that ChatGPT can use in order to communicate with their machine, like coming up with, making their own little tools essentially to have an AI help them with their own personal workflows that they use on a daily basis. There's like the biggest user of Smithy for us outside of Disney is SiriusXM, mostly because a lot of people are Sirius came from Disney, and they are really like adamant users of Smithy for us. They help with a lot of contributions, like very valuable stuff come from Sirius in the open source project. And they have, I think they have some pretty interesting like data translation or data evolution, like database migration tools that are driven by Smithy for us that they've written in against those abstractions that I was talking about. So yeah, it's really like a tool set or a foundation, like a set of foundations to build your own tools, as opposed to something that is going to claim, like it's not a framework, essentially, in the sense that, yeah, you can build HTTP services on top of Smithy for us, but you're going to have to put in the work. You're not going to be able to just get everything out of the box like you would a traditional framework like Spring or Play or whatever.
Okay. I would like to remind our viewers that it is possible to ask questions on both Twitch and YouTube. We don't have any questions yet, but we are slowly moving towards the end of the podcast. So I still have one more thing to ask. We now know what the current state of Smithy is, to some degree, of course. I wanted to ask about the future of both Smithy as the IDL language maintained by AWS, and Smithy 4S, which is maintained by you.
Yeah. So regarding Smithy itself, well, I'm not really privy to what AWS is in the shop. Like they're working on, they have a bunch of code generator tools that they're actively working on. Like they're very deeply invested in Smithy, and they've got a lot of people working on collateral tooling, and they've got code generators for Kotlin, for Rust, for a bunch of languages that are being worked on in the open source, primarily for AWS protocols, like the AWS REST-JSON protocol, but also for like architecturing, I think, their content solution in order for other use cases to be implemented. And one thing that they've said they were going to do in the near future is basically publish the Smithy specification for all the AWS services onto Maven Central, which means that you could build pure AWS SDKs for your own programming languages, whether it's like that's what we've done with Scala. We've got an AWS, like a work in progress / prototype-ish AWS SDK thing. But this would sort of lower the bar of entry for other languages to build their own AWS SDK if they want to do so, which like when you're a new language, it's really interesting to be able to do that. So I'm quite happy with how they're doing this. It's really nice. As for Smithy 4S, so there's a few sort of features that we're actively working on. Like this week, we're probably going to release a feature that's going to allow to capture unknown JSON fields within data types. So let's say you've got a case class and you also want to capture, like you receive a JSON payload and you want to capture all the fields that are not directly encoded in the case class in a map of a string to JSON, for instance. That's something that we're going to facilitate. And then we're sort of slowly refining our implementation, and the design being what it is, like very flexible, very polymorphic in a way. It's sort of an open research case in a way. So we're learning a lot as we're implementing things as to what works, what doesn't, what trade-offs we need to accept, and we're slowly sort of improving the internals of the library. So the next big version for us, and I can't really give you a time frame, it will be the 0.19 version of Smithy for us. Currently, we're in the 0.18 lineage, and for 0.19, we're gonna sort of solidify the internals, add maybe alternative cogeneration flavors in order to have, instead of generating case classes, for instance, generate classes that would have a little bit more like what AWS does, essentially, that would be friendlier to binary compatibility and source compatibility with accessors as opposed to case class fields, and privatizing the copy methods and this kind of stuff. Yeah, and other than that, hopefully make a little bit of progress on the AWS SDK front, but that's sort of more of a like when time permits kind of thing, as opposed to a priority of the tool.
Mm-hmm. I have to say that the last bit that you don't really have a priority of which is the AWS SDK, is something that I would say is most interesting to me. And given that I have some experience with generating SDKs based on shapes of APIs by hyperscalers, I'm really interested in how you are going to approach the sizing problem, which is what is the biggest problem usually, as the jars tend to get really big.
So it's, unfortunately, we don't have a good solution for that. Like we are roughly on par with the official Java SDK in that, like, to give you the worst example, is EC2. The EC2 spec is absolutely horrendously huge. And I think the Java SDK is probably, like, for that particular service alone, it's probably like 20 megs worth of bytecode. And I think we're sitting somewhere between 23 and 25. So it's sort of, a similar level of size, but when you have static languages, it's hard to cut down on that. Like, if you want to give something that provides a good user experience to your users, you have to sacrifice on the size somehow.
Yeah.
And unfortunately, we don't have a good solution for that particular one.
Yeah, there's just a lot of information.
Yeah, exactly.
Yeah. Okay, I think we'll be finishing now. So thank you for coming and
my pleasure.
Sharing all the information about Smithy with us. And I don't see any questions from the chat, unfortunately.
No, it's fine.
That would be it. Thank you so much.